Yesterday, we talked about all of the definitions and concepts in section 2.4. We talked about what a function is and how you find a function value. We talked about the domain of a function. What does that mean if I say find the domain of the function? Find what you can let x be that doesn't blow up the function. And so far, that refers primarily to watching out for what makes the denominator 0 or what gives you a negative under a square root symbol. We'll find other things that blow up functions later. What we didn't have time to do yesterday was the examples in 2.4. I just have a few circled in my book that I want to go over with you, and then we need to do our best to get through 2.5 today. On page 132, I'm not going to try to recopy that graph on my paper, but here's the graph we're looking at. I think I said 22, I meant number 20. Number 20 asked us for several different things. The first thing it asks us for is the domain of that function. And for what values of x is that function defined? In the interval notation, what values of x is that function defined? Yeah, just say what's the leftmost x for which the function is defined? -5. What's the rightmost x for which the function is defined? 7. And is it defined for everything between -5 and 7, or are there any holes and dots, or holes and gaps in there? No holes and gaps, so it's defined everywhere from -5 to 7, including both the -5 and the 7. Is there?
6.
What am I not seeing that you're seeing? Here's 7. It's defined at 7. It's defined at -5. It's defined everything between -5 and 7. What? 2 people are going, what the heck? Tell me what's bugging you. Are you looking at y values instead of x values?
Like there's no 6, there's no 4.
6 and 4 aren't labeled, but they're there. F of 6 is right here. Well, let's see, 1, 2, 3, 4, 5, 6. 7, 6 is right here. It looks like it goes through the 0.60. It's not labeled, but it's there. Samantha, what's still bugging you? I can tell you're not okay with that yet. I'm just saying, what's the leftmost x? -5. What's the rightmost x? +7. And there's a solid line, not line, but solid graph from -5 to 7. The domain is just the x values. Dylan, you were frowning too. Is that okay now?
Yeah, I got you.
Okay. All right. The B part says give the range of that function. And range refers to what? Y values. So you just look at the graph and go, what's the lowest y value? What's the highest y value? And does the graph hit all the y values in between? What do you have for the range of that function? -1's the lowest y value. +2's the highest y value. Does the graph hit all the y values in between? Yeah. So it's -1 to 2, including both of those endpoints because the graph actually hits a y value of -1 and a y value of +2. The C part says find f of 1. Now, if you had given me an equation and told me to find f of 1, I would have just put 1 in the place of x, and that would have been f of 1. But you didn't give me an equation, you gave me a graph. How do I find f of 1 by looking at the graph?
Where x equals 1 on the graph, and that's -1.
Yes, that notation is giving you an x value. If I said find f of 2, you'd put 2 in the place of x, not in place of y. F of 1 means put 1 in place of x. So 1 is the x value, and f of 1 is the y value when x equals 1. So we're looking at the graph, and when x equals 1, y equals negative 1, that's the function value f of 1. Just to make sure you got it, what's f of 6?
0.
When x is 6, that's right there, y is 0. F of 6 is 0. What's f of 0? When x is 0, y is 0. So that's how you pull function values off a graph when you're not given an equation. You're just looking for the y value at this particular x. The D part says find all x such that f of x equals 1. What's interchangeable with f of x? What can you always put in the place of f of x? So that means find all the x's where the y is 1. What are all the x's? This is the answer. What are all the x's where the y is 1? Negative 3. Say them to me loudly, Miss Samantha. Negative 3.
Negative 1, 3, 4.
All right, I wrote it down. Let me check it. Negative 3, negative 1, 3, and 5. Yep. And then the E part says find all x such that f of x is greater than 1. And again, y is interchangeable for x. So we're looking for all the x's such that the y is bigger than 1. What do you think that answer is? Negative 2, certainly that would be true. 4, that would certainly be true. Are those the only 2 points on the graph where the y is bigger than 1? The answer is no, but why? Got an idea? You have an idea?
It doesn't go that far.
Doesn't go that far. What do you mean by it doesn't go that far?
Everything above negative 3 to negative 2 is a part.
Ah, it's not just these 2 points. Those are the only 2 labeled points where y is bigger than 1. But this point, maybe negative 2.5, is also the y is bigger than 1. So when I ask you for all the points where y is bigger than 1, I'm not just asking you for the label points. I'm asking you for all points. You'd have to write that as an interval. For what interval are the y's bigger than 1?
From negative 3 to negative 1. And
Yeah,
3 to
from
5.
here to here and from here to here. With these instructions, would you have parentheses or brackets on those endpoints of the intervals? Yeah. At negative 3, the y is not bigger than 1, it's equal to 1. So don't include that endpoint. But anywhere between negative 3 and negative 1, not including the endpoints, and anywhere from 3 to 5, not including the endpoints.
So you do put a union.
Yes, yeah, put a union symbol. I mean, it's not like it's wrong if you don't put the union symbol, but that's what they'll have in the back. That's this and that. Contains all the answers to the question. All right, so number 20 was interpreting a graph. Number 30 says find the domain. What does find the domain mean? Find the x's that you can use that don't blow up the function. And so far in our algebraic life, what two things have we learned will blow up a function? Negative under the square root or 0 under in the denominator of a fraction. All right. What could I not use in that expression?
3.
I definitely can't use 3. Yes, it can't use anything lower than -3 because that will give me a negative under the radical. What about -3 itself? Can I use -3?
Well, no.
Because that would still give you 0 in the denominator. So I cannot, let's see, if I say cannot have, then that needs to be an equals. I cannot have x equals 3, and I can't have x is less than -3, or I can't even have x equals -3. So how do I write the domain if those are the values that are excluded?
It would be,
You can graph it on a number line if it helps you. All the numbers, I can't use anything less than -3.
so -3 to constant. No, it would be -3 to 3. With brackets.
I cannot use anything less than -3. I can use greater than -3. This is -3. I can use anything bigger than that except for what? Except for 3. I can't use 3. And we said we could not use -3 itself, so that's going to have a parenthesis on it. If you're unsure, just check. Check something less than -3. Could you use -4? No. Could you use 0? Could you use 0? Yeah. You could get a negative answer, but that's not a problem. It doesn't blow up the radical. It doesn't blow up the denominator. 0 is okay. What about 4? Could we use 4? Yeah, we can use everything bigger than -3 except for 3. So in interval notation, that would be from -3 to 3, not including the 3, and then from 3 to infinity, not including the 3. All right, number 48 gives us a quadratic function, f of x equals -2x squared plus 5, and asks us to find something called the difference quotient. It tells you what the difference quotient is. F of 2 plus h minus f of 2 divided by h. That's just a recipe. Not a recipe for disaster, a recipe for the difference quotient. And we're just going to follow that recipe step by step for the function that we're given. What does f of pig mean? F of pig. Put pig in place of all the x's. What does f of 2 plus h mean? Put 2 plus h in place of all the x's. So that's the first part of the recipe. Put 2 plus h in place of all the x's in this function. That's going to be -2. And instead of x squared, I have 2 plus h squared. And then I have my plus 5. Everything that I just wrote is the first step in that recipe. It's f of 2 plus h. Take whatever is in those parentheses and just plop it down in place of the x. What does the next step of the recipe say?
Subtract that.
Subtract what you get if you put 2 into the function. I'm going to make the most common mistake here. You tell me what it is. And it's the same old common mistake we're always trying to avoid. I want to subtract that whole f of 2, then I have to have the whole f of 2 in parentheses. Make sure you've written in your notes. This is f of 2 plus h. This is f of 2. And then what's in the denominator of that recipe? Does it say, does that mean put h into the function? Does it say f of h? No, it just says h. So, okay, there we go. The rest of that is simplify as much as possible. You would have to either write down or in your head, multiply 2 plus h times 2 plus h. We have got to pick up the pace just a little, so I'm going to do a little bit in my head, but you could put in more steps if you were doing this in your homework. 2 plus h times 2 plus h would be 4 times negative 2 is negative 8. And then I'd have 2h and 2h is 4h times negative 2, negative 8h minus 2h squared. That's negative 8 plus 5 is negative 3. Let me double check that. Yep, that's right. All right, I skipped a step. I skipped 2 steps. But if we were going more slowly, you could get there. Combine like terms. And that's a plus 3, by the way. It got kind of sloppy. This is negative 2h squared minus 8h minus 5. Oh, crap. See, that's why we shouldn't skip steps. Even if I am going fast, I need to still write down the steps because I made a mistake and I just found it. All right, those of you writing in pencil, you're still good. Me, I just need to not try to do that step without writing it down. Yeah, that's right. Maybe you don't have to see it right now. Write it down so you don't get behind. And you can figure out the middle step at home. You really could if you know how to fold. What happens when we evaluate the limit of the difference quotient? Every time, a whole lot of stuff eliminate each other. This is a negative 8. This is a positive 8. That's gone. And we're trying to simplify this as much as possible. I could take 2 more steps to eliminate this, or to simplify this just a little bit more. What could I do that would simplify it further?
You can take h
out of the numerator. You could factor an h out of the numerator. Actually, you could factor out a 2h or a negative 2h. The only reason I didn't factor out a 2 is because I don't have anything to cancel with it anyway. So I just left it in there. Wouldn't be wrong if you factored it out. I only factored out an h because an h was all that I had to cancel. So that's negative 8 minus 2h. if you're thinking, why the heck does anybody care about the difference quotient? Well, if you go on to calculus, then you're gonna see that's almost the definition of the very biggest thing in calculus. The very other top three things in calculus, but one of the top three things in calculus is the derivative, whatever that means. This is darn close to the definition of the derivative. When we get to calculus, we'll say that, and then attach to it something you don't have to worry about now. I'm just giving you a preview of calculus. If I say the limit as h goes to 0 of -8 minus 2h, that means if h gets so small that it practically disappears, what's the only thing that's left there? -8. It's going to turn out in calculus that that's the derivative of that function when x is 2. You don't have to know what any of that means now. I'm just saying this is very, very relevant to calculus. You're going to see it again if you go to calculus, and by golly, you better be proficient at it. One of those things you've got to be able to handle. So let's do one more, number 50. We have a different function, 1 over x squared, and we have a slightly different recipe. The recipe this time is f of x plus h minus f of x divided by h. Slightly different recipe. What does f of x plus h tell you to do?
X plus h for x.
Put x plus h in the place of x. Instead of 1 over x squared, we have 1 over x plus h squared. That is f of x plus h. What's the next step in the recipe? What? Subtract the function itself. Subtract 1 over x squared. That's f of h, or f of x. And then I'm supposed to divide the whole thing by h. In pre-calculus, I don't even know why I'm doing this, but I can do it. It's a recipe. I can follow a recipe, and I'll find out in calculus why that recipe is so important. Now, here's the algebra part. How do I clean that up? That's a complex fraction. Little fractions within a big fraction, that's a complex fraction. How do I simplify a complex fraction? You multiply by the LCD, and the LCD of these two baby fractions has to include both the x squared and the x plus h squared. So I'm going to make sure I distribute that LCD completely. When I multiply that whole LCD, this is the LCD, when I multiply that whole LCD times this first term, what's going to be left? The x plus h squares will cancel and just leave me the x squared. When I multiply the LCD times the second term, what's left? X plus h squared and then the denominator is going to become double ugly, h times x squared times x plus h squared. And then I'm going to go fast again. Say x plus h times x plus h, distribute that -1, I'd have negative x squared minus 2xh minus h squared. When you have the difference quotient, the numerator's always going to have some stuff that will cancel. Give you 0. What are the only two steps you could do that would simplify that further? You could factor out an h. So that you could cancel it with that h in the denominator. That lacks just a tiny little something being a derivative. If I attach that limit as h goes to 0, then it would be a derivative. But right now we're practicing the algebra. Calculus will attach that limit as h goes to 0 and figure out what that means. All right, I have two other problems that we're not going to finish, but I just want to set them up. We've got problems similar to them in the homework, and I want to make sure that you know what to do. Number 54 says, find a linear equation that satisfies these two conditions. Find a linear equation that satisfies those two conditions. I found linear equations in last night's homework. There are two scenarios in which I can find a linear equation. I either have to be given a what? A slope and a point, or I can be given 2 points. Give me either one of those things and I can find a linear equation. What the? What the F? What the? That's a video now. What the function? What am I given there? I'm given 2 points. That first f of negative 2 equals 7 is the ordered pair negative 2, 7. F of 4 is negative 2 means when x is 4, y is negative 2. So what's the first thing I have to find? The slope. And after I find the slope, what can I use to get that linear equation? Actually, either point slope form or slope intercept form, whichever you like to use. All right, that's all I'm going to say about 54. And then 68 is an application. Let's see. Says an aquarium of height 1.5 feet is to have a volume of 6 cubic feet. Let x denote the length of the base and y denote the width. Express y as a function of x. All right. Can you do that without a picture or would a picture help? That's the picture to number 67. We're working on an aquarium. That's an office and a waiting room. I think a picture would help. And an aquarium is probably one of the two things that I can draw in through 3 dimensions. Because my 3-dimensional capabilities are seriously limited. Here's my aquarium. What do we know? The aquarium has a height of 1.5 feet. That's also known as the depth of 1.5 feet. let x be the length of the base, call that my length, and let y be the width. And the only other problem or number that I'm given is that the volume equals 6 cubic feet. So that's everything I know about that aquarium. And I want to find an equation that expresses the width as a function of the length. Got any ideas? What's the one thing that we know here? Actually, we know two things. We know the height is 1.5. We know the volume is 6. Do we know how to find the volume of an aquarium? Do we have an aquarium volume? Yeah, we don't have an aquarium volume formula, but we have a rectangular solid formula for volume. It's length times width times height. That's what volume always is. So what could I put in the place of volume equals length times width times height, and that's supposed to equal 6? What am I using for my length? X. What am I using for my width? Y. What am I using for my height? 1.5. That's just a big ugly way of writing 1.5 xy equals 6. So if you want a formula for y in terms of x, how could you get the y by itself? Hocus pocus, put it over there, or do something legal to get it over there? Is it added? Divide. Divide by 1.5 x. And the simplest way to write that, you don't want to leave a decimal within a fraction in your answer. That's just 4 over x. So whatever the length is, you divide 4 by that length, you'll get the width. All right. That took way longer than it was supposed to. So let's see what we can get said. Tonight, at a very minimum, the homework is this. At the bottom of the 2.4 notes. And then we're going to see how far we can get into 2.5. Section 2.5 is graphs of functions. In pre-calculus, you can't use a graphic calculator because we want you to have a rough idea of what a function looks like as soon as you see the equation. I want you to look at it and go, well, that's going to be a line. Well, that's going to be a parabola. That's going to be a snake-shaped graph. And then in calculus, you use a graphing calculator, but if you don't already have that quick mental image in your head, then you may have trouble interpreting some of the graphs on a graphing calculator. So this is just a review of everything we know about functions. We already know linear functions. How do I see an equation and go, oh, that one's linear? How do I know it's going to be a line? First degree. So a linear function is a first degree function. And if you give me an equation in slope-intercept form, I can just graph it using the slope and the y-intercept. These 4 little graphs, all I wanted to say was a graph going uphill from left to right. What do you know about its slope? You know it has a positive slope. A graph that's going downhill from left to right, what do you know about it? It has a negative slope. Tell me what you know about a horizontal line. Does that have all? That has all the same y's. That's okay. That has all the same y's. So the equation is y equals a constant, and what's the slope? Yeah. Going straight across, not up or down, the slope is 0. And then tell me what you know about a vertical line. What's the equation going to look like? X is a constant, and what do you know about the slope? Undefined slope. So that is your quickie review of 2.3. What you need to know about quadratic functions, and how do you recognize a quadratic function? What makes you go, ooh, this is going to be a parabola? Second degree, y equals x squared. It's y to the first equals x squared. If both variables are squared, it's something we don't have time to talk about today. But if an equation is in standard form, then you can just look at it and see the vertex. The vertex of that parabola is going to be h, k. H is always the opposite of the guy in parentheses. K is the constant added on the end. And the leading coefficient tells you whether the parabola is concave up or concave down. If you have a positive coefficient for A, if A is greater than 0, you're going to have a concave up parabola. If A is less than 0, then you're going to have a concave down parabola. If the equation's in vertex form, like I said, you can find the vertex, or you can see the vertex is opposite of the guy in parentheses and the guy on the end, HK. If the equation's in general form, that little formula ring a bell? Negative b over 2a is how you find the vertex of the parabola. You peel off the coefficients a and b, plug them into that formula. That's the x coordinate of the vertex. You plug the x in to get the y coordinate of the vertex. Square root function, we're just going to fly through these. It's half of a sideways parabola. Now, what is our default method of graphing? If you forget all this library of functions on the test, how could you still graph these functions? I'm sorry, what? I just can't hear you.
An XY chart.
An XY chart, absolutely right. If your brain totally goes blank, you make an XY chart. The hope is that you don't have to make an XY chart because you just know your library of functions. X cubed, I like to call him a vertical snake, but you won't see that in the book. I made it up. And that's snake, not shake. Y equals cube root of x. I call that guy my horizontal snake. It's just x cubed turned on its side. Just like the square root of x is half of this parabola turned on its side, cube root of x is this snake turned on its side. The absolute value function, if you put in a positive number or 0, you get out the same thing you put in. If you put in a 7, you get out a 7. If you put in a 10, you get out a 10. If you put in a 0, you get out a 0. If you put in a negative number, you get out the opposite of what you put in. If you put in a negative 3, you get out a positive 3. And that's why the graph of the absolute value function is V-shaped, because half of it is the line y equals x. Remember the line y equals x bisects the first quadrant? The other half of it is the line y equals negative x. So when you see y equals absolute value of x, I just want you to go, oh, that's the one that's V-shaped. If you know this library of functions, then you can apply everything you know about horizontal and vertical shifts. If I add or subtract something before I apply the function, that's a horizontal shift, and that horizontal shift always works the opposite of what I expected. Adding actually moves it to the left, subtracting actually moves it to the right. the constant that's added after I've applied the function, that's your vertical shift. Adding moves the graph up, subtracting moves the graph down. And then a negative coefficient flips the graph upside down. That's why y equals positive x squared is this, but negative x squared is that. So the only other thing, and we're going to have time to do maybe everything but these last two, we may not have time to talk about them, but when I see number 4, I automatically recognize square root of x is half of a sideways parabola. And if I told you to find f of 8, for example, would you subtract the 4 before you took the square root or after you took the square root? Before. That means it's your horizontal shift. And that horizontal shift always works the opposite of what you might have guessed. Subtracting 4 actually shifts the parabola 4 to the right. So if you have that in your head, you don't even have to write it down. If you have, that's a half of a sideways parabola shifted 4 to the right, then 1, 2, 3, 4 to the right. That's how quickly you can graph it. And number 5 is the same thing, but with a negative coefficient. What would that negative coefficient do? Takes this, flips it over, so you have the bottom half of a sideways parabola. Number 2, what shape is that graph? Because of the y equals x squared, it's a parabola. Because of the 4 being positive, what do you know about that parabola? Concave up. It's a concave up parabola. And what's its vertex? It's been shifted 3 to the right and up 2. So its vertex is 3, 2. Now, if you just ask me to graph that, I don't need to write anything down. I'm writing that down so you'll have it in your notes. But if you just ask me to graph it, then here's the mental image that I'd have almost instantly. What about number 9? What do you know that shape is? A V shape, and how has it been shifted? That 2 is added to the x before you take the absolute value, so it's your horizontal shift. Horizontal shift works the opposite of what you expect, so it's shifted to the left 2. It's the same V shape, shifted to the left 2. So as soon as I see that, there's my instant mental image. And it's plenty good enough that if in calculus I needed to graph that and it came up with a circle, I'm smart enough to go, whoa, that's not supposed to be a circle. What about x cubed minus 5? What's it supposed to look like? That horizontal snake shifted how? Here's the horizontal snake. And it's supposed to be shifted 5 to the right. Now this goes against everything that a biologist will tell you. I'm going to tell you that's the snake's belly button right there at the origin. And you know snakes don't really have belly buttons. But to shift that 5 places to the right, I'm going to shift its belly button 5 places to the right. And calculus will give it a better name. And calculus will call that the inflection point. But in pre-calculus, we call it the snake's belly button. It's been scooted over to right there. It looks like x cubed turned sideways. What about this one? That is what shape? Vertical snake that's been shifted how? That 2 is added after the cubing, so it's a vertical shift. And the vertical shift works like you expected. So up 2.
So number 6 or 7, would that be?
Hang on to that just a minute because that's different. We haven't talked about that yet. Like the snake's belly button first. And then make it be an uphill snake. Number 3, what shape is that? It's a parabola, and does it open up or down? Concave down parabola. How do I find the vertex? Because it's not like number 2 that I can just look at it and see the vertex.
Peel off A and B.
That little formula, negative b over 2a, will give you the x coordinate of the vertex. Once you have the x, how do you get the y? Plug the x in and get the y that goes with it. All right, we've had time to talk about everything except this turns out to be a semicircle, and those 2 bottom dots are called piecewise functions. Those are the 2 that we didn't get to. So in tonight's homework, 2.5, let me just look at those real quickly and tell you the ones you don't have to do because we didn't talk about them. Number 13, you should be able to do it. 15, you can do it. 17, you can do that. 19, you can do that. 47, where is it? 47, okay. We haven't talked about 47, 49, and 51. So in addition to 2.4, I just want you to do those 4 problems. And you think, yay, that's only 4 problems? But A, B, C, D, E, F, G. Number 13, for example, is actually going to have 3 graphs. It's going to be V-shaped. So you show me a V that's been shifted down 3, up 3, whatever else it says. All right, y'all have a good weekend. Hey, start getting ready for the test. The practice test is in momentum. Your test may be Thursday, but I'm forgetting. It's not on the top of my head right now. Look at the calendar, see when the test is, and be getting ready for it.
Oh my gosh.
You showed me that.
I'm sorry, what? Oh, yes.
How does it say 19 after 1?
This is every other odd. So 1, not 3, 5, not 7, and so on. On that sequence, you would skip number 19, but 19 is important, so I threw it in there after every other odd. That makes sense, my wacky way of thinking?
Yeah.
Okay.